So from chapter 1 to chapter 3, there is no contact that we have seen. We didn't mention the object contact with what and what, right? We didn't mention what kind of contact. Does it hole in the pin? Does it round surface, contact with the surface, and so on. So today we'll learn about the contact. So this chapter will link with your test 1, question 2 question. Okay. Uh, yeah. Um, okay. Today we'll focus more on the support reaction. We call it reaction. Support reaction. The rest you already know how to do free body diagram. You already know how to what is equilibrium condition, or the force equal to 0, or the moment equal to 0, and you have been learn about the scalar method and vector analysis. Right. Okay. So this is just a refresh. Just a refresh. You have learned chapter 1 to chapter 3 to transform the left diagram into right diagram. We combine all the forces into the right hand diagram, right? So here you see 3 forces, F1, F2, F3. You already learned how to combine this F1, F2, F3 into one resultant. Then you also learn how to combine M1, M2, M1, M2 into MR at O location. Okay. In chapter 3 also you learn when you transfer forces parallel to the axis and perpendicular to the axis, something will happen if you transfer the force. Right. Nothing will happen if you transfer the force parallel to the object. For example, this is the force parallel to the axis of the object. You can transfer the force from the front to the back. Okay, this is what you learn. However, if you transfer the force that is perpendicular to the axis, you move this force to the back, something will happen. If you move to here, the force magnitude still same, direction still same. However, if you move from here to here, this is the F multiplied by D. It will generate another moment over here by FD equation. Okay, so this would happen. Moment is quite easy. Moment, you just add them together. Okay. Okay, so this is what you learn. All the force you combine together become 0. Force and moment become 0. And this one only apply in statics, engineering statics. If you go to next semester or coming semester, you go to dynamics, this one do not apply anymore. Just in dynamics, object keep on moving. Okay. This is a derivation on summing all the moment. For example, moment at A. So this one, you have resultant and resultant of force and moment at O. Okay. So chapter 1, chapter 3, you learn how to convert the top diagram to bottom diagram. This is what you learn, right? Now, today, maybe a bit reminder. So you transfer these two forces by referring to A. So previously you focus on O, but now you are referring to A. So as you can see, the equation become, if you move moment and resultant force at O, and you move these two to A, your equation will become R cross F. So what is R? R is here. Right hand rules, R cross F. And you can extend the tail of the forces, R cross F. All right. If you see cross, means this is a 3-dimensional question already. If you see cross, means it's 3-dimensional question. Scalar method only F multiply D only. Then plus M R O. So means moment on the body, you can move anywhere you want. It's still same. Okay, so if you look at the equation, the R, the distance from O to A cannot be 0. I mean, this one cannot be 0. So the force must be 0 because R cannot be 0. So R must be 0, moment must be 0. Okay. Okay. So when we apply these two equations or equation of equilibrium, we assume that the body is rigid and do not deform. We assume that the object that we analyze is rigid and do not deform. So in your report also, lab report, you can mention this one in your results, because you also have error in your results, and in your report also you need to make comparison between your theory value and your experiment value. So this one, why the value is different from your experimental data, is because in theory, in equation, we assume body remain rigid and do not deform. There's no loss of energy there. Right? Okay, the rest you read. The rest you read. Oh, okay. This one is just saying that why we can still use these two, because most of the material that we use nowadays, they have a little deformation. So we can just ignore. There's error lah, but you can still accept. So free body diagram, just to revisit what is free body diagram. Free body diagram is just need to sketch the outer bodies of the object. Okay. So, but anyway, when it comes to your test or final exam, when you ask to sketch a free body diagram, you can represent this aircraft with a square, or rectangular. So this one, for example, this aircraft, you start to see there is a center of gravity, G. So start from today, all the mass under gravitational force, acceleration will create W weight, will go through the G center of mass or centroid. Okay, so in your free body diagram, always show that your W is go through the center of mass. Okay, so there is a specific chapter in statics, or last 2 or 3 chapter, you need to calculate the centroid. Right. So in your experiment also, there's one experiment that you need to calculate the center of the object. Right. So, and then here it show you that you start to see contact surfaces. So when you have object have contact with any surfaces, there is a normal forces. Okay, in this case, you see R means reaction force, means you put any object that on the surface, there is a reaction there. There's a reaction there. So normal force N is a reaction force. Normal force N is a reaction force. But for this module, we still remain to use N, capital N, for normal contact forces. We will use R when we use when you see pin or any locking mechanism built inside the wall, or so, for example, we will use R to differentiate the N. This one is another presentation. Okay, another presentation. Not necessary it's 2T, but it can be contact surface, because aircraft have 2 wheels behind, so 2T there, for example. Okay. Okay. When you need to write 2T, for example, in your answer, if the question give you a lot of information, for example, the object have 3 wheels, 1 wheel in front, 2 wheel behind. If the question mentioned 3 wheels already, means you need to consider another 2 wheel behind. So there are 2 contact forces. Or if you're lazy, also can, you represent this one as 1 forces. Then you calculate this one as 1 parameter. Then if the question asks you what is the reaction force for one of the wheel behind, then you need to divide by 2 lah, you answer. That's that. Okay, so this is just need to be careful when the question give you a lot of information. You need to give detail in your free body diagram. Okay. Okay. Now we look into support reaction. So there are 2 general rules. What is a function of support? What is a function of support? The support here can be a pin, can be built inside a wall. It can be a roller. It can be anything. Transfer the motion. For example, the support here is to prevent translation. What do you mean by translation? Translation means x in the straight line motion. Translation that means translation. So it can be x, can be y, can be z. As long as move in the straight line, it's called translation. Under the reaction of a force. So if you give a force, the object will sure move one. So you move in a straight line. It can be any direction as long as straight line. Then we call it translation. Okay. Another one. A support prevent rotation means moment. Moment. So rotation, it prevent it from rotate. So you need to be careful on the type of the support. Some support give you can eliminate moment. Some support you need to put in moment in your solution. So for example, roller. The first type of support, as you see on the screen here, roller. Roller means what? You can push the object, right? What is the object motion if you push, right? So you can move like that. So one, okay, my secret in drawing support in your free body diagram, you imagine what cannot do by the object. Then this one become your reaction. Okay, so this is how I remember on a reaction. For example, if you look at the diagram, the object can roll to the left, right, it can go up, right? It can go up. So there's no reaction force in left, right, up, and even no moment because it can roll. But there's one force there. It cannot go down. Okay, it cannot go down. So if you press the steel, if you are the object, you press the steel, you are feeling something punching inside your bodies. So the force reaction pointing to the bodies. This is how you remember the reaction. Okay, first type is roller. You have many types. For example, pin. This one is very famous in civil engineering. Let's say you have a pin. You will see this kind of presentation. There is a pin with the 2 screw nut here. It represents pin. Even though the question do not give you the 3-dimensional presentation, if you see this presentation, pin, sometimes you'll see only like this. This also represents pin, even though there's no screw there. As long as you see a cone shape. Sometimes you will see triangular shape also. Triangular shape with the pin at the center also represent pin. So again, can you try to draw the reaction for this one? You draw the free body diagram. You draw the steel. There's a hole there. So what we're interested in, what happened to the hole there. Okay, so again, imagine what cannot do by the object if it is locked by the pin. Can the object rotate or not? Can. So no moment. Can the object move left, right? Cannot. So there is a left-right forces. Okay, so this one, it depends on the external forces. In general, I would just like to put something like this. Okay, can be like this, or because I want to make my equation positive, I will always do this direction. Means go up positive, go to the right positive. So some of you might ask, Dr. Ang, can I draw this direction? Can. You can draw any direction you like, but at the end of your solution, you'll get negative. If the real situation is not what you draw, you'll get negative value in your calculation. Okay, again, in your free body diagram, there's no negative sign inside the free body diagram. Only in your solution, you will see negative value. So when you in your solution, if you see negative values, means something wrong with your prediction. Your free body diagram is your prediction. Okay, so I will highly recommend as a start, you draw according to the standard direction. Go up positive. For in this case, I will mark this one. Let's say it's point A. I will just write this one R, A, Y, and I label this one A, X. Yeah, so you see something like this. Fy or Fx, you can, in this case, because there's no label point, so the you use capital F. So if final exam or exam, you will see a point. You're given point A, point B, point C, point D. Then you change the capital F here into the alphabet of that represent that point. Okay, or you can write F sub A Y if you want to write something like that, also can, right? But for simple answer, just need to use the alphabet to represent as a false, right? Or in my slides later, when you see reaction false, I will purposely change the color into green or purple color. Okay, so you know that when you have F and Y forces, you can calculate the resultant. So when you solve question in statics, after you find F direction, X direction, Y direction, or Z direction, the next step is to find the resultant force and find the angle. Always the same, from chapter 1 to chapter for all the chapter. Okay, so you convert the free body diagram with the contact into this form. Then after this one, only you convert back to resultant force. Okay, don't straight away draw this one unless you are seeing a rope or something, a cable. Though if it's a cable, then you need to follow the cable. Then only you flip back become, if this one is cable, there's one cable here. Then you need to split. But now we're focusing on the contact. Now we focus on contact. So contact, you see pin, you split into X and Y direction. And no moment because the object can move, can rotate. Okay, so the principle here is to imagine if you're the object, what direction you cannot move. Okay, what is your constraint? For example, the third one, the third support with built inside the wall. Okay, this one in construction, in civil, this one happen most of the time. You do piling, you do all these things. So you imagine you are the object that built inside the wall. What direction you cannot move? You cannot turn. Means when you cannot turn, then you have moment already. So in this case, the direction here also you're free to write. In this case, this is clockwise direction. As a standard procedure, we will always use anti-clockwise. But if you can draw clockwise, no problem. Again, if you draw clockwise and then you do analysis, for example, all the moment equals 0, at the end you get negative, you need to redraw your free body diagram. If you get negative, means you need to flip the direction of the moment. Same with the forces also. Okay. Yeah.
include moments in this type of
support.
supports because it's coming to rotate, right?
It cannot rotate. It cannot rotate like that. It cannot move. Yes. So this one, you transform, you see the support into this diagram. You imagine what cannot do by the object. This object cannot turn, cannot move, moment. It cannot turn clockwise or anti-clockwise. So there's a moment there. Okay. And the blue color arrow here, the moment is free. You can draw clockwise or anti-clockwise. But most of the time in question, you arrive at clockwise direction for your info lah. Most of the time. But you can start with anti-clockwise, no problem. But what is important in your free body diagram, when you see fixed support or inside the wall, the question will say the object was built inside the wall, then it's a fixed support. Convert the support, the fixed support into this diagram. Two forces with one moment. Okay. This one is 2D. What happened in 3D? 3D means you add one more Z direction because it cannot move in Z. And there are 3 moments for all the axes. Okay, so if you go to the appendix that is inside the Canvas, or you go and download the tutorial question for chapter 4 in the Canvas, you'll see there's a long table for all the support. So I won't go through all. This is your homework, and you go to see. What I want to highlight here is that you need to imagine what cannot move or what cannot do by the object. Then you transform the support into forces and moment. Okay, so for example, cable. If it was tied by the cable, your forces should follow the cable direction. For example, why the arrow pointing to the here is because the object feeling that the cable is pulling the object. That's why the arrow is pointing out. Always think that always imagine you are the object and then ask yourself, what do you feel? If you feel the object punching you in, then the force will be pointing in. Okay. Number 2, weightless link. Weightless link is there's a link there. So this one happened more in the mechanical engineering rather than civil. Civil also have but rare. You see this one. So link means there's a object that link to this one. So you also same principle with the cable. Also same. So it can be either pressing the object or pulling the object. So you can draw either these two. Then in your analysis, if you're in your solution, you find negative, then you flip the direction, flip the arrow. The third one, roller. This one is very popular in all the final exam question. So roller means there's a ball there. So roller, they always one contact surface. Maybe this one is not clear. I want to highlight the 90 degree here. As long as you have a round body, no matter what is the configuration up there, as long as you're round body, there's always one contact point. There's one contact forces, which is 90 degree to the object. No matter what is let's say I give you a slanted surface. Okay, there's a roller up there. The contact point is here. Normal force is 90 degree to the surface. Okay. So don't draw this diagram as here. If you draw like that, this is wrong. There's no normal force like that. Normal contact force is 90 degree for all the round bodies. Okay, take note this one. when you draw free body diagram, as long as you see angle, remember to copy the angle to the free body diagram. Okay, so angle you already seen in chapter 1 to 3. Sometimes you're given angle, sometimes you're given the ratio, the triangular ratio, 3, 4, 5, and other lah. Okay, for example. Okay, so these are the example. For example, on the bridge, there's one cable here. So there's a force. You need to convert this one into free body diagram, and then there is a force that follow the cable here. Okay, follow the cable here. Okay, so for cable, your arrow always pointing out one, not pressing. Pressing is when you have a spring. Okay, the other lah, rocker. Same. Rocker here, you see there's a round surface. There's a round surface below there. Rocker, roller, they are the same, always 90 degree. You see there's 90 degree here to the surface. To the surface, not to the object. To the surface. To the surface. Smooth contact surface. This one also popular in the question most of the time. In question 2, in your test 1, you will see smooth surface. So if you see smooth surface contact 1, although there is no matter what kind of object, it can be rectangular like this. So let's say you have a rectangular object or square object, and the question tell you that you have a smooth surface. The contact force always 90 degree to the object. When you see smooth, then you have a normal contact force or reaction force. Another one also roller. This one also roller. Confined in the smooth slot. Smooth slot is like the link in your window sometimes, right? If you push the link, I'm not sure this one have or not. This one don't have. So some doors or some that have link, there's a slot there, they can slide along. So this one, when you have one object, don't overthink. It's only have one contact force. Don't draw another force at another direction. You only have one forces here. Although it's happened in the slot, so you only need to consider there's only one contact force in the slot. Okay, in the slot. So this one, what happened in the slot? Okay, so for example, there's a slot there. Then there's a roller connected to the arm. So this one can slide. So when you draw this one of slides, there's only one contact force to the surface, for example. This one also, member pin connected to the collar with smooth rod. So this one, there's a smooth rod right there. Then it can slide. So same also, as long as it can slide along, and when it slide, it became like a round body. So you also see one contact force, but it's perpendicular to the body, to the surface. Perpendicular to the surface. Okay. So something like this, rocker support. Okay, this one is in construction. Bridge to relieve from expansion of materials. This one you see under bridge. Okay, so or in the highway, under highway, right? This one also. So this one, sometimes you have a gap there for thermal expansion. So this one can expand left, right. So this one is number 5, right? Number 5. So this one, in civil, when you have a concrete grinder, rest on a ledge, you assume as a smooth contact surface, which is number 5 here. Okay, so here, in this case, maybe there's one contact force here. You can assume it's like that. Okay. The rest you read. So for example, this one, member fixed connected. Fixed connected means this one cannot move. When the object cannot move, means you need to consider moment already. When you see the word fixed, there is a moment there already. Means this one object cannot turn, but it can slide. When this one can slide, then there's a contact force. But this one cannot rotate. Then cannot rotate, there's one moment. Same here, fixed, you see the wall already. See? This one fixed to the wall. It cannot go left, go up. It cannot rotate. So there's a moment, there's a force there. Okay, so these are the 10 types. These are the example in the application. Right, some beam there. Okay, internal force, this one, there's one chapter. We'll go into one specific chapter after your test one. We'll go inside here. But in this case, we'll just focus on here. This one. So this one, you transfer this. This is a roller. Your focus is on this black color object. You imagine you are this black color object. What do you feel? You see wall already. You see there's a wall at point A. Wall cannot go left, right, cannot rotate. So you transform contact or support or reaction at A with AY and AX with the moment. Okay. Then you will see one reaction here. Right? You are sitting on the round bodies. Right? You imagine you're sitting here, right? You're feeling something punching your body, right? So there's a force pointing up at point D. Okay, we learned about distributed load already. So don't confuse between these two. For example, this one 30 kilonewton, this one is focus concentrated forces. However, this one 10 kilonewton over meter is from here to here. So in chapter 3, we already learned about distributed load. Okay, but today we focus on the support. So this one, we will learn this one in chapter 5 or chapter 6 maybe. We will cut the object and see what happened inside there. Okay, at the moment, you don't need to worry about this one first. Okay, this is just a touch and go. Just will let you know that they always have an internal force when you cut the body and split them theoretically. Right, theoretically, you split the object into half. Then you need to balance the force at the cutting point there. For example, if you cut at point B, you cut the point B, then there is a two forces pulling to each other, and there's a V means shear force. We'll come to this one later. Okay, we'll come to this one later. Today we focus on support. Okay. So for free body diagram, for chapter 4, you don't need to worry about what happened inside the body there. You only need to look at external forces. For example, there's a centroid and center of gravity, acceleration of gravity will pull the object down because of the mass. So it become W. This one will be the standard. Will be the standard. Unless the question asks you ignore the size of the object, or in the question, you're not given the mass. Okay. So if you're not given the mass, there's no W. Or sometimes the question asks you answer in certain terms. Put your answer in W terms. Means you write your equation in equation. Right? You represent weight equal to mg. So you solve your question, put your mg inside your answer. Means something, your answer, for example, F equal to 10 kilonewton plus 4 mg, for example. Or 10 kilonewton plus 4 W. Yeah. So your answer can be in this form. Last year, last semester, I come up with one question, ask the student to write in some terms, in W terms. Some students don't know how to do. Means you don't need to find the answer for W, but in your answer, you need to put W in your solution. Yeah. Okay, the rest you read. This one is just an application from the real scenario to the analysis steps. So here you see a construction with 3 trusses that support on the beam A to B. So again, if you draw free body diagram, imagine you are focused on that object first. Don't look at other object. Focus on that object. For example, this one, AB. Then think, what do you feel? Right. In this case, you feel three bar here, or 3 object here is resting on you. Resting on you means pressing on you. You are feeling something pressing you. So there's arrow pointing down at that particular distance. Then here, this one in the table just now, I already show you already. This one equal to this one. Okay. So this one roller, for example. So this one, although there's no roller there, but this one free to move, right? If this one you expand, this object expand because of the thermal expansion, this one can move to the right. So there's a roller there. Okay. Okay, so this one is pin because this one it allow it to rotate like that, up and down. So it like a pin. Okay. So this one another presentation. Sometimes you see question only I give you one picture. Then you need to convert the picture into free body diagram, something like this. So this one is a crane, or there's a mobile elevator. So you have point ABC. Then there is a stand there. A person stand here. So you need to draw the figure on the left to on the. I want to highlight this point G here. This one will be careless mistakes most of the time. You can do analysis, but you forget weight in the free body diagram. Just don't forget lah. There's a reading material there on how you do analysis. All right, I won't go through line by line. You go and read. Okay, let's look at example 1. We're now focusing on free body diagram. We don't do analysis already. Okay, analysis you already expert, already done in the chapter 1 to 3. So for example, this one, you're given this one. You're given the mass. Are you able to draw free body diagram? So maybe I give you 30 seconds to try to draw. Then I review the answer to you. The object here is the steel bar. It's a uniform beam. It was inside the wall. So wall, you have what? Imagine what cannot do by the object. So there are 2 forces at point A and then 1 moment at A. Again, moment, you can draw any direction you like. It can be anti-clockwise, it can be clockwise. By the standard practice, we will draw anti-clockwise following right-hand rules. So you have a positive value in your calculation. Okay. So this one is rather simple. You copy the object and then copy the external forces. For example, in this case, you copy 1,200 Newton. Copy the dimension. Okay, the dimension is important because you need to solve using all the force equals 0, all the moment equals 0 at a certain point. But today we don't go into analysis. We only focus on support. So I review the answer to you. So see if you're able to see. Okay, some of you already forget this point in first steps. Remember W, remember W in your answer. Without W, your solution for all the force equals 0, all the moment equals 0 were wrong. So start from free body diagram, you draw wrong already, your answer wrong for the analysis already. Okay, so for your lab report also, although I'm not the one who marked your lab report, try to put in the weight in your lab report. Object, explain what happened to the. Okay, I'll just highlight here lah. So in your free body diagram, don't go and substitute value first. Because I've seen throughout the semester, careless mistakes always happen at here. If you substitute wrongly, I don't know, maybe that day you are not feeling well, you write the wrong number here, then you screw up the rest of your calculation. So don't substitute value first. Write equation W equal to mg, or you can just write W over here. And then draw arrow at the center. You draw one dot for the center. So in this case, this one, the total length is 6. Put in 3 meters in your free body diagram. It can be from the left or from the right. It doesn't matter as long as you show the location. Then you draw W. Okay. Then only you consider contact point or support. So in this case, how it behaves, you use third Newton law, means there's a reaction there. That there's an opposite reaction according to the Newton law. So if you pull, it will pull you back, right? For example, right? If you pull, it will pull you back, and so on. Okay. So in this case, the arrow of AX and AY, you are free to choose. But I would highly recommend you follow the typical direction. Go to the left, positive, go up, positive. But again, if you draw something like what you see on the screen here, also correct. But at the end, when you do analysis, you get negative. For example, you get AX equal to negative 10 kilonewton. You need to redraw your free body diagram. Flip the direction accordingly. Okay. So this is the things. Then only you complete with values. Then only you calculate values. After you do all the numbering, then only you calculate the values. Okay. Okay. Example number 2 is something in the mechanical engineering. So you're having a mechanism or spring there, a spring latch. Sometimes it's because of your brakes or throttles, right? So there's a link here. There's a like an inverted L shape, and there's a force because of your feet here. You press on the pedals here, so there's a force there. Then there's a link B, and there's a spring. You're given a distance. There's a pin. There's a distance. Here is in mm. The spring here is in kilonewton over meter. So it's highly recommend you convert the unit into unit SI first when you solve. If you see spring, you see anything that in meter, convert answer into meter if can, to avoid careless mistakes in calculation. Okay, so before we move on, you're given spring is stretched 50 mm, force on the link is 100 Newton. You should be able to find, right? So this one like a cable. So when you press on here, if you are the object of this L link, what do you feel? You feel something pulling you, right? There's a force pulling you. All right. So same with this one, spring. Spring F equal to what? KX. Again, today we don't go into analysis. We just want to expose you to how to draw a free body diagram. Here, this one, pin, got how many force? How many force? 2 forces in X and Y. In this case, although they here do not have X and Y, you draw your own X and Y. X and Y. And then this one free to rotate, so no moment. Okay. So again, remember gravity effect. So if not given, skip. If the question you don't see any how many kilogram, skip for the mass. Okay, skip for the mass. So in this case, mass is not given, so no need to put in weight. I flip back. You see question 1. Question 1, you see mass 100 kilogram. So you need to put in W here. Okay. So contact point, I give you all. So for example, AX, AY, again, follow the traditional direction. Left positive, go up positive. And this is just show you, just to show you. Then you put in the value. After you label, then only you substitute value. You do this one at the side of your, some area inside your working sheet there. You write F spring or force for the spring equal to Kx, then only you substitute Kx multiplied by the extension here, 50 mm, you put in there in meter. Okay, so this one is not our focus today, the calculation. Right, so these are the diagram, should be. Okay. So again, draw the bodies. Highlight here, draw the body. Don't give me one dot and then, or you just draw one line. Don't draw line. Draw the bodies. For example, you don't draw something like this. Don't draw this and then give me force. You'll get wrong answer. Draw the bodies. Okay. So example 3, there's a trailer, there's a forklift pulling up the 2 power or two pipe. You're given mass there. You're given mass each 300 kilogram. So if you're given mass, remember to put in W in your free body diagram. Support by fork. Draw free body diagram for each of the pipe and both pipe together. You need to split the diagram into 2. You need to draw 3 diagram for example 3. One is combined. Then you split into 2. Okay. So how many contact force you see over here? What's the reaction force first? How many? You look at the yellow and the gray color. How many contact? 3. One here, one here, one here. There are 3 contact force. Then you only consider the weight mass. Where's the mass? Or this round body, where's the mass? Center. Mass is over here, the dot for all the round bodies or any bodies. Although it is hollow here, the weight is over here at the center. Okay. Then if you split them out together, you look at individual bodies, you just ask yourself, what do you feel if you are A? What do you feel if you are B? Okay. So if you are A, what do you feel? You feel contact force here, and there's a contact force here. If you are A. Right? What do you feel if you're A? You're feeling something pressing you, right? By B. So the arrow is pointing towards A if you are A. Same with B. Even though B is on A, if you draw B, you feel A is pressing you also. So the arrow pointing towards B. Yeah, then find all the reaction, all the forces by using equation of equilibrium, all the moment equals 0, all the force equals 0. Split into x and y direction if you are giving 2-dimensional question. If you're 3-dimensional, most of the time you need to do vector analysis already. Okay, I give you the answer. So again, draw the bodies, draw the arrow of the degree, copy the degree, copy the degree. So I'll just highlight, draw the slanted line through the center of the bodies, the 30 degree. Remember gravity effect. This will be the careless mistakes most of the time. You'll forget this one. Okay, so label properly. If this object A, you write W sub A equal to MAG. WB equal to sorry, it should be B, M sub BG. Because inside here, there's no 2. Here only have B, so write MB2. Or you write somewhere in your answer, M2 equal to 300 kilonewton. Okay, then I put in the contact there. Okay, contact 1, 2, 3. Of course, in the real case, you don't need to write the full one. You only need to write N 1, 2, 3, 4, for example. Okay, remember the angle, 30 degree here, 30 degree here. 30 degree means 30 degree from the force and the vertical axis. This also, the 30 degree also, there will be the careless mistakes. You will forget this one. So take note on that. This one you need to copy, especially when you have an angle. Okay. Okay, then only you substitute. When you draw free body diagram, consider the W first. If you're given the mass, then there's a W. If not, in the question, do not give you the M, then no, you can ignore this one. You can skip. Then you go to the contact point. Here, there's no external force. If there are any external force, if there was tied with the cable and all these things, then you need to put in the external force in your free body diagram. Okay. Okay. So when you split, this is A with the resultant pressing in. So I start to use green color to represent resultant. Same with the B. B is here. Okay. So in the another chapter with this resultant chapter, internal force chapter, this green color is actually considered internal force already. Any question for example 3? Any question? No. Is it okay we go for another 20 minutes, then we call it a day? Yeah. Okay. So again, today our focus is to practice on the contact surface, not on the analysis anymore. Right? Yeah. Analysis will be chapter 1 to 3. If you're not sure how to do all the force equals 0 or the moment equals 0, go and practice. Okay, this one. You're given a crane with all the cables, and this question actually give you hints that give you G, right? You need to smart enough to identify. There's actually we do help you in the question sometimes. We give you G means we highlight. You need to put in W already. Okay, so this one give you mass 200 kilogram. So there's we expect you to draw W from the G point here, capital G here. If you draw somewhere else, means wrong answer. Okay, so you have a pin here. You have a pin. You have a cable. You have a mass. So how many force you have? 1, 2, 3, 4. You have 4 forces. Right? No moment. Okay, no moment on the diagram. However, when you do equation of equilibrium, you need to use moment equation, equilibrium, to find any missing parameter. Although no moment inside the diagram, but equation of moment can help you to find the unknown. Okay, so these are the things lah. I just give you the answer. Remember to put inside the dimension. Remember to copy all the dimension in your free body diagram, because this one will help you to solve all the moment equals 0 equation. Okay, just in case you forget, after you draw free body diagram, you want to solve using all the force equals 0. Remember to split all the forces into X and Y direction, especially this one, the cable tension. This one with 70 degree, you can split into Y-axis and X-axis. Then only you do analysis, all the force in X equals 0, all the force in Y equals 0. Then you do moment. Moment, because you see this one, the loss of things there. Do moment at that point. Here got two unknown. You don't want to solve these two unknown. Put your finger there, do moment at point A. Then you can solve what is the tension at T already. Yeah. Of course, you can put T also. You can put moment here also, if you want. All right. But here got angle. All right. Got angle. We try not to disturb the angle. Right. Okay. Equation of equilibrium. This one you're familiar. Means you put all the force into 0, all the moment equals 0. Here just need to highlight is the moment location. So here this is just a general equation. This is just a general equation. When you write moment, remember to tell us where is your reference location. This O means there's a reference there. So this is the one that you see in the question. So you need to combine all these four forces, F1, F2, F3, F4 into one resultant, or when you do analysis, split all these forces into X and Y direction, then you group in X, group in Y, you solve. Okay. So you combine this diagram into resultant diagram. Okay, you already learned this one in chapter 1 to chapter 3 already. Okay. So this is just highlight. You can okay. So again, moment you can look at different location if you want. Right? This is just to highlight. Again, procedure for analysis also your reading. Just go and read lah. So we try to solve example 5. So you are given example 5. Standard procedure is to draw free body diagram first. And in fact, in the question, we will give you direct instruction. The first part always asks you to draw free body diagram. So here, free body diagram, we ask you determine the horizontal vertical component of the reaction of the beam caused by the pin at B and the rocker at A as shown in figure. Ignore the weight of the beam. So ignore the weight of the beam means you don't need to calculate the W. There's no W in your free body diagram if you see something like this. All right. Now, you have three forces there. Copy these three forces in the free body diagram. So draw this gray color object. Don't draw the wall. Draw this free body diagram. And then there's a pinhole there, pinhole there. This is a round body. This is a pin. Okay. So I hope you know how to draw already. So copy all the external force. Copy all the dimension from where to where. All right. So this is 100 Newton, 200 Newton. Put in unit, 600 Newton. Then only you draw reaction. So since W don't need, so W don't need. Of course, you don't need to draw like this. So then you label point A, point B. So point A can move to left, right. Right. It can rotate also, but cannot move down. You press down, cannot go down. So when you press down, what do you feel? You feel something pressing your bodies. So you just write AY. Then B. B also can rotate because it's a thin. Then B, I just follow. I just follow my normal direction, B, Y, and BX. Then you do analysis. If you get negative, then you need to flip the direction. Okay. You should know how to solve already by now. So how you solve? Before you solve, remember to split all the forces into X and Y. So this one you just label. Okay. Should be. So you can create your own. In your free body diagram, you can do this one, C equal to this one. So this one you write CY, CX. Then at your side of your diagram, you don't want to mess up your diagram there. So at the side of your diagram, you write CY equal 600 sine or cos. CY is sine or cos. Your theta is here. Sine or cos. Is it sine or cos? Sine, sine 45. CX equal 600 cos 45 Newton. But because this one is calculation, go up positive, go right positive. So AY go down, remember put negative there. This one as a side calculation. No negative in the free body diagram. This one is your side calculation. X is go to the right, so positive. Okay, then it asks you to solve, right? So all the force equals 0. You write all the force equals 0, all the moment 0. This one 1 mark, this one 1 mark. You write like this. Then split this one into all the force in X equals 0. You write this one, maybe there's another 1 mark. Maybe it depends on the complexity of the question. Okay, or sometimes it straight give you this one 2 marks. All right, so all the force in Y equals 0, you substitute you find all the X direction, Y direction, and then you write all the moment 0. Remember, I'm looking for this location. What do you refer to the moment? In this case, if your free body diagram that I draw on the whiteboard here, the most complex thing to me is point B. So I close B. I go to stand at point B. I do moment at point B first. When I do moment at point B, I do not see Bx and By. I only see 100 Newton. I see this one, Cy, Cx, I see Ay. There's only one unknown. This one I have, this one I have, this one I have. I don't know this one. Then this one, remember to tell me the direction. X positive, go up positive, moment anti-clockwise positive. So this one, 100 multiply 2 meter, you get positive, negative moment. Positive or negative moment. This one, 100. This one. You put a B. What is the moment you create? Clockwise or anti-clockwise? Anti-clockwise, so it's positive. This one create positive moment. A generate negative moment. Cy generate positive moment. Cx generate negative moment. Yeah. sorry, Cy, Cx 0, because D 0. Cx do not generate moment. Cx, yes. Cx, 600 in x direction, there's a 1.2, there's 0.2 meter here. So there's a moment in this direction. So clockwise negative. You sum up these three equation. You have three unknown, A, Y, B, Y, B, X. You have three unknown, three equation is sufficient. Okay? Any questions so far? We don't go deep into the substitution. As long as you understand, oh, this is how I do. Okay. Can? Okay, I'll show you the detailed analysis. You draw the diagram. You label accordingly. Right? So there's no C in the diagram, you just create one. You can put P, you can put any alphabet you want. But as long as you label, then in your analysis there, you use what you put in your free body diagram. Okay, then you put in resultant or support. Okay, in this case, I think I miss out my AY, X, RBX there. Yeah, there is. Okay, so this is a complete one. Then you solve. Look carefully, there's a 0.2 meter. Some of you might miss the 0.2 in the moment equation. So then you solve lah, Then you solve. The answer for RBX is 424. RBY answer is 405. Resultant for at A 319 Newton. This just for your check lah. You substitute and this one. Okay, the detail of this one we already covered in chapter 1 to 3. We don't go deep into that. We assume we already know. What I want to highlight is give us the direction that what mean by positive. Go left, go right positive, go up positive, anti-clockwise positive. Okay, so in this case, you get all positive, means what you draw in the free body diagram is correct. Okay. Okay, this one. The cord with the support 500 Newton, what around the frictionless pulley, determine tension in the cord at C, this one, and the horizontal and vertical component reaction at pin A. Pin A. So you need to split into a few diagrams if you want, right? So you can see as one system. So if you are pulley, you're actually feeling there's a cable here. Cable always pointing out the force. Here also pointing down. Okay. Then this one is a pin. This one can rotate, so no moment. It cannot move up, cannot move down. So you have two forces at point A. Give direction of X and Y yourself. X, Y. Then C is follow the direction of this one. Okay. Okay, free body diagram. You draw body first. In this case, you're not given mass, so ignore weight. Okay. So you at point A, copy all the parameter 30 degree. Why do I give you the dotted line? It's because at round bodies, you always work at the tension. At round bodies, you always move in the tangent direction. At round bodies. So that's why I draw the dotted line there. You copy 500 at tangent direction. Okay. Then you pull the T there. You are looking at A, not the cable. So don't confuse. Contact point, then only you follow the contact point. You do the external force, then only you look at the reaction force or the support. Okay, in this case, you have RA, RX. Again, the green color arrow, you're free to choose any direction you like, but I highly recommend you draw the left, right positive, go up positive. In this case, RX to the left. Okay, just to show you what happens if you draw like this, and then later the answer is something. So equation of equilibrium, all the force 0, moment at A 0. Why moment at A 0? Because we want to eliminate the reaction at A. Once you put there, your hand there, RA, RX is disappeared in moment equation. The dF multiply D equals 0 for AX and AY, and you only see T and 500 Newton. Okay. So here you have 30 degree. Remember, after you do analysis, for analysis, remember to split all the angle into X and Y. For example, this one, the T have 30 degree, split into X and Y direction to solve for all the force equals 0. Then moment you need to be smart enough to choose any point that you have a loss of unknown. In this case, A have a loss of unknown. You sit there, RX, RY, AX, AY gone. You only see this one and this one. Remember, this one you got two forces. One is this direction, one is this direction. Okay. So I just help you a bit. So you will see for A, this one is in the tension direction. So 500 multiplied by the radius. Radius is 0.15. Tension also 0.15. What is moment? Force multiplied by perpendicular distance. This is around bodies. So D is a 90 degree to the force. So you don't need to split the forces in X and Y. Even you split X and Y, later you get the same answer. Okay, you get the tension cable by the first equation, moment equal A. Moment at A equals 0, you get tension 500. Then B, for the X direction, Y direction, Rx, here, because my free body diagram are pointing to the left, that's why I put negative there. If your free body diagram is pointing to the right, then Rx become positive. Okay, I just show you that what happens if I put my RAX to the left. In my calculation, I put negative there. Okay, then you need to split your T into X direction. While you repeat, you'll get 900 something. Okay, another one. So remember, shown in here, you have a pin there connected at A, rest again a smooth support at B. So smooth support, even though it's smooth, but also got contact. Smooth means you assume as a round bodies, there's one contact here, 90 degree to the surface. Okay, determine horizontal and vertical component reaction at pin A. So here you should able to draw the free body diagram. So just a quick one. See if you're able to draw free body diagram for the link, for the arm there. You should able to draw. So you copy the link. There's a moment. There's a distributed load here. Okay. Label A, B. There's a pin here. Okay, before you solve for the external force first. Moment you have already. This one, distributed load, convert distributed load into concentrated load. This is a triangular. there's a concentrated load for this one. Distance will be quarter of from the base, from base. This is the base, This is the base. So in this case, you know that the question asks you pin A. So the distance to this force will be 2/3 distance. 2/3 L. This is the L. Detail of this one also in appendix. Go and download and read. Okay. Convert into concentration force. So this one I will write. How do you calculate the concentration load there? It's a triangular or area under the graph. This is the base. So 800 Newton meter multiplied by 1.5 divide half. This is half of the rectangular. Okay, so press calculator. 800 multiply 150. This one. Just put in the equation. W is a distributed load. Multiply by the length. This one, because it's a triangular, so triangular divide by 2. Okay, you should be able to see this one actually is a rectangular, but half rectangular. Okay, so once you convert all the external force inside the system, then you only look at the diagram. So here weight is not given, so you don't need to consider the weight or the mass. Now you go for the contact. Move surface 90 degree to the arm. So you write this one is B. You can just put it B. Then here, get free to rotate, no moment at A. But it cannot move left, right. So there's A, Y, AX there. So how many are known? AY, AX, and B, 3 are known. Use three equation. All the force equals 0. This one split into 2, X direction, Y direction. So all the force in X equals 0. All the force in Y equals 0. And another one, all the moment equals 0. Remember to give me where's your reference. In this case, we don't like AX, AY, so close there. So write all the moment at A equals 0. So in cos here, you are seeing B, you are seeing F, you are seeing moment here. So F you can calculate, you only have one unknown B. Once you find B, substitute back here. Here got angle. It's angle 30 degree here. So here is a zigzag. If you don't know how to transfer angle, 30 degree. So this is a Z. So here is 30. And then you split up lah. Okay. So I just put in there. This one, distributed load becomes 60 Newton. Okay, refer to canvas. There's a appendix there. So where's the direction from base? From the base. This is the base of the rectangular. So 1/4. So total length is 1.5. 1/4 is 0.5 here. So the length from A to the focus point F, 16 Newton there is 1 meter. Contact point, put in there. Then solve. Okay, by using equilibrium equation. You substitute You get the answer. RB 200, RX 100, RAY 230. This one, just a quick one, huh? This one, example 8, some of you do exercise, you like to do some push-up. So at point A, there's a board there. So board means you fix the object. So reaction force here, you cannot rotate, so there's a moment here. Cannot rotate, so there's a moment here, and there's a Fx, Fy for A. Here, pulling 52, given you a ratio 5, 20, 30. So the angle is over here, the theta is over here, so use the theta, then use the ratio over here. Here got 60. So we expect to see ratio in your answer. We expect to see theta in the degree in your answer. So here we expect to see sine and cos. Here we see 5/12 or 5/13 in your answer. Okay. So try to see. So free body diagram, I just put in reaction with the moment at A. In this case, I just assume anti-clockwise, positive. And AX, AY in direction. Then I solve by all the moment at A, because I don't like the 3 unknown at A, so I put it there. Moment at A equals 0. When you put here, your force gone, but there's a moment there. Remember to put your moment A in this equation. Even though moment A is, you put there, force do not generate moment, but there's a moment here. So MA plus this one, plus this one, plus this one, plus this one. So you have 1, 2, 3, 4, 5. 5 moments in the equation, all the moment at A equals 0. So you have 5 components there. Then Fx you get 3, Fy you get 3. Then you solve. So you get all the answer like this. Okay. RAX 5, RAY 74, MA is 32.6 Newton meter. In this case, anti-clockwise direction. Okay. And because you have AX, AY, you can calculate the resultant. So sometime in the question will help you. We'll give you further instruction. You need to find resultant in your answer. So after you find Rx, Ry, square this one, square root, you get the resultant. Use the tangent theta, inverse the tangent, you get the theta. Okay, so this one you get resultant, but I don't go forward after this, but you should know how to do if the question asks you to do. Another one, your homework, go home and have a look. Example 9, right? Same. This is a round bodies and so on. Example 10, also go and see. Example 10 is lots of roller there. Free body diagram look like. There's only one reaction force at the support. No, do not have 4. So don't draw 4 green arrow on the body. Don't double the arrow. Especially for these two, it tell you already. So this one also you go and see the homework. This one also go and see. Example 11. There's one time I come up one question, something like this in test or final exam, I forget already. Okay, so this one also your homework, go and see. This one also 11, 12 also your homework, go and see. Got question, come and ask me. Okay, I think we stop here, and I see you tomorrow. Okay.